Okay, well, anyone who knows me knows that if it is a Mantle All-American 5 radio from the late 40s through to the late 50s, and the cabinet's in good condition, and it has all of its knobs and it has its back, I'm going to buy it. This is a beautiful Crosley. I'm not sure the model yet, I'll have to track that down, but it is in great condition. The cabinet's in great condition. There's no dings or scratches that I can see. It's probably been refinished, and I haven't opened it up yet. Hopefully, hopefully the power cord is in behind. Apparently, the story goes that a hobbyist had this radio and was working on it and wasn't able to get it going, either because he was missing a part or something else. So I accept the challenge. That sounds like fun. May be able to fix it, maybe not. We'll see what happens. This is the first time I'm looking at it. I'm not quite sure what we're going to find here, but let's take a look. It's interesting that we have these kinds of screws rather than the typical screwdriver screws. I think is there something on the bottom holding it in? No, that should be it. Maybe not. Yeah, something holding it in. Okay, well, let's just take a step back and we'll see what we're working with. Okay, well, we do indeed have some chassis screws here that we'll have to remove. And what have we learned? Well, there's the power cable, so that's a good sign. And the previous person working on this left a little note that says Crosley needs IC. OPCO IC 5159 32-87024-1. So the last number there is probably the part code. An IC, well, not an integrated circuit in the sense of a chip like we would think of now, but my guess is this has what's known as a couplet, which is a little device that includes within it often some small value resistor or small value capacitors and sometimes resistors and so on. So if that's missing or not working, then we'll have to see what's going on. But let's take a look inside. All of the tubes are there. We'll have to test those a little bit later on. All right, now usually I work on radios that have been worked on before, because if a radio has survived 70 years, it's likely that somebody's worked on it, at least replacing the tubes, but often the filter capacitors as well. But this one's been worked on recently, so that's unusual for me. Let's see what we have. Okay. Oh, well, they have the speaker covered, so that's good. And I see he has replaced the capacitors, both the filter capacitors and these little signal caps here. And there's our couplet. So, a couple things we can do. First thing I want to do is find out what exactly the model is, and then maybe we'll be able to track down a schematic and we'll see what's in that couplet. But I could also test it. Well, let's first find out what we're working with. Okay, well, I found the model. It is the Crosley JT3, and as you can see here, it comes in several colors: the brown, such as I have, a black, a painted orange, and a green. And it's commonly known as the Swiss cheese model, for obvious reasons, for this wacky kind of grill that it has. And the dates that you most often see are 1953 and 1955, so it's probably somewhere in that range. I doubt that we'll find a date code because the previous hobbyist working on it has replaced the capacitor, so we won't have cap codes to go by. But it does have an interesting look. It's I was kind of surprised that it has the miniature 12-volt tubes in it. I thought those came out a little bit later, after 1953 and 1955, but presumably the dates are correct here. So from that, I did manage to find a schematic from the Radio Museum. And you can see it's a typical All-American 5, your 5 tubes, etc., etc. But here is that couplet that they're referring to as a printed circuit. And this gives me the values for the components within that little couplet. There's a 10 meg resistor. There's two 470K resistors. There's two 0.005 microfarad caps. And then there's 3 caps that, according to this, together, combined value is 100 picofarads. So we'll have to figure out, because 2 of them are in parallel, so that's going to impact on the value. So we'll have to figure out exactly how that works and see whether we can, if in fact this couplet is bad, see whether we can replace these with discrete components and wire them just point to point. So we have a battle plan. Let's see how that goes. So I've tested the tubes. Everything is fine except for the 35W4 rectifier, which appears to have a little bit of a heater to cathode leak. So we will replace that. I've got plenty of those. And maybe we'll power it up and give it a test. So now we're going to do a little bit of audio testing. As usual, I have the radio hooked up to an isolation transformer, and in this case also a current limiter and a variac. And I've bypassed one component of that couplet with a 0.005 microfarad capacitor just sort of pinned in here, and I'm injecting a signal at the input of the volume pot. So let's see whether that does the trick. Yeah, and that responds to the volume pot. So that part, bypassing that, and you can hear, yeah, you can hear the issue in there. All right, maybe we can get away with just bypassing some of the components. See what happens. Next test. If we bypass that 0.005 microfarad cap in the couplet and we inject a modulated IF signal directly into the variable capacitor, in other words, emulating kind of reception, RF reception, do we get a signal? And it sounds like we do, not a very good one, but we do get a signal. Okay, so I removed the couplet from the circuit to test it. Of course, first I carefully recorded what all of the pins were connected to. And here's what I came up with. So pin 1 to 2 should be 0.005 microfarad capacitor, and in fact that's what we have, so that's great. 1 to 4 should be a 10 meg resistor, and it's reading 22 megs, so that's a problem. 3 to 4 should be 125 picofarads, it's reading 150 picofarads. 4 to 5 should be 470K, and it's reading open. 4 to 6 should be 470K, and it's reading 1.1 meg. 5 to 7 should be 470K, and it's reading open. And then 6 to 7 should be a 0.005 microfarad, and that's what it is. So the problem is with this, these resistors, not so much with the capacitors. So we might have to bypass those. Let's see how we make out. Okay, so that couplet is in between the detector, or AVC, or audio frequency tube, and the output amp. So let's take a look at the resistors. So there's that 10 meg resistor, which is huge, which is the grid leak resistor for the 12AT6. So it's not good if that's 22 megs, but the amp probably would still function, or the tubes would probably still function. Then this resistor, 470K, is feeding from the screen grid, is feeding AC, or sorry, DC, to the plate of the 12AT6. So that's not going to function at all. That's the resistor that's open, so we'll have to replace that. And then the other 470K is right here, so that's a grid leak resistor for the 50C5. And then these 0.005s, one is essentially a signal cap, and the other one is also a signal cap, so we'll have to replace those. Then these smaller picofarad are filtering RF out of that signal. All right, so let's see whether we can replace this whole thing with discrete components, and perhaps we can get this radio working. Okay, so, whoa. I added the discrete components, and I cleaned up the previous guy's work a little bit. And now I have a signal generator attached directly to the variable capacitor, and we're going to get a good strong signal. So that 12AT6 obviously is now conducting. And I think what I'll do next is attach the antenna and see if we can get any kind of reception, and then I might do an alignment. Well, it's not perfect, but I have a signal, or I have a picking up the station. All right, well, I'll do an alignment off camera, and we'll put this whole thing back together again. Well, I had to take it out of my shop. It was so noisy in there. But I think it still needs some work on the reception, but anyhow, sounds pretty good.
With the voice remote from Rogers Ignite, you can spend less time